Welcome, learners. I'm particularly going to be talking to my JC students who are writing the 2026 JCE exams. We are going to revise this paper together. This is the 2024 JCE Physics. All right, so like I always say to all my students, that you need to know the structure of your paper. Okay, so this is physics. Physics has 33 questions, which are split into 3 sections, namely A, B, and C. All right, and in total you have 33 questions, and you're supposed to answer all the questions. So JC candidates, 2026 JC candidates, let's gather here. Let's revise this physics paper together. We shall also come back with other subjects. All right, so if you know fellow JC candidates, please invite them to this revision. It's going to be of help, I'm sure. So today we are going to go through this 2024 paper. We shall see how far we can go. We'll start with section A right away, which has 20 marks. All right, question number 1. Which of the following best defines a scientific investigation? All right, a scientific investigation is defined as the systematic way of finding out solutions to problems. Therefore, the answer is D. All right, so make sure you know the exact definition of a scientific investigation. All right, however you define the term scientific investigation, make sure that it is a step-by-step procedure. It's a step-by-step method of finding answers to scientific problems. And so the closest answer to this question is D, the systematic way of finding out solutions to problems. The word systematic means that the process is step by step. It's a step by step, it has steps. Remember the stages of a scientific investigation. You start with identifying the problem. So you start a problem, you start by identifying the problem. Then once you have identified the problem, you formulate the hypothesis. All right. Having formulated the hypothesis, you go on to test the hypothesis. That's where you do the actual experiment and so on. And then you have other steps too. All right. So make sure you know the definition of a scientific investigation. And also, you have to know all the stages of a scientific investigation. All right. Number 2. Before we get to number 2, there's a statement here which you shall need to answer questions 3 and 4. Figure 1 is a graph showing the relationship between the temperature and the volume of a gas. Use it to answer the questions 2 and 3. Okay, so let's appreciate the graph. So we have a graph here of volume against temperature. Since volume is placed on the y-axis, it means that it is our dependent variable, and the temperature should be our independent variable. It clearly shows that as the temperature increases, volume also increases. That's why it is a straight line graph. So in other words, we can say that volume is directly proportional to temperature. Why are we saying that? Because the graph line is a straight line. It shows a direct relationship. So which of the following is the correct interpretation of the graph? This clearly shows that as temperature increases, volume also increases. Therefore, the correct answer is D. You have to know the different shapes of graphs and their meanings. Alright, so this particular one shows a direct relationship, indicating that as temperature increases, volume also increases. So take note, so it cannot be A. Why it is not A is because as the volume increases, temperature remains the same. No. Yes, volume is increasing, but temperature is not the same. So it's not, cannot be A. As volume increases, temperature decreases. No, temperature, both temperature and the volume are increasing, so it cannot be B. As temperature increases, volume remains the same. No, volume is not the same. It also changes accordingly, proportionally. It changes in response to the change in temperature. So the correct answer there is D. All right, number 3. Which of the following is the volume when the temperature is 15 degrees Celsius? So let's go back to the graph. When the temperature is 15, somewhere here, we need to find a corresponding volume. So all we have to do is draw a dotted line upwards, and then we go horizontal. We call this interpolation. Yeah, so the volume in question should come from this point here. To do that, all you have to do is to determine the least count on the scale. If this is 20, it means that this is 10, so we have 10, 20, then 30, 40. All right, so the volume therefore corresponding to this point must be 30. Must be 30 cubic centimeters. All right, so therefore the answer to the question should be C. So the answer should be C. All right, number 4 and 5 depend on this diagram here. Figure 2 is a diagram showing two poles of a magnet. Use it to answer the questions that follow. All right, so let's look at it. So here we have two magnets. Okay. So we have two magnets. And the field lines here are indicating that the two magnets are repelling each other. There's a repulsion between the two magnets. Okay. So for that to happen, it means that the two poles must be identical, must be the same. All right, so let's quickly identify the poles. When you are looking at a magnet, suppose this is a magnet. Remember that field lines of a magnet always originate from the North Pole. Field lines originate from the North Pole and terminate at the South Pole. Suppose we have a North Pole this end and the South Pole this end. So the field lines will go like this all the time. They point away from the north and they point towards the south. All right, so in this case, the field lines will go like this. Okay, and they'll come out of the North Pole and enter the South Pole. Okay, like this. All right, that means, therefore, this end here must be north. And since they are repelling, that means the other end is also a North Pole. Please check that this is the case. All right, since there is repulsion, it means that the two poles of the magnet are similar. Remember that like poles of a magnet repel, and therefore this must be north, this too must be north. So the answer to the question should be D. Once again, take note, we are saying that when you have a magnet like this, say that this is north, this is south, field lines always come out of the North Pole and they enter the South Pole end. Alright, and if you look at this diagram here, you find that the lines are originating from both ends, from M and N. That means, therefore, both poles must be north. So there is repulsion there. There is repulsion. There is repulsion between the two magnets. So the correct answer, therefore, is D. D. All right, number 5. Question number 5. Number 5. The curved arrows shown in the figure represent the electric field lines, the magnetic field lines, the direction of conventional current, the direction of electric current. All right, so these are called field lines. Therefore, the correct answer is B. The correct answer is B. All right. Once again, my name is Mr. Pochilola, your teacher. I'm presenting this revision exercise or revision lesson to my Form 2 students. Wherever you are, if you are Form 2 student or if you are a parent and you have a Form 2 child in your house, please share this video to them so that they can revise in readiness for their JCE exams, which are coming in a very short while from now. All right, which of the following nuclear radiations can easily pass through different materials? All right. Okay, so we have alpha particles, beta particles, gamma rays, UV radiations or ultraviolet rays. All right, this is quite a bit tricky, but in terms of nuclear radiations, let's just check if all of them are nuclear radiations. So we have alpha particles. Yes, it's nuclear radiation as well as a particle, beta particles, and gamma. The first three are indeed nuclear, yes, nuclear radiations, but D is not a nuclear radiation. Therefore, we shall rule out D and focus on A, B, and C. All right. So in terms of ability to pass through matter or materials, which is called penetration, the C, which is gamma rays, is most highly penetrating. All right, so the answer to that is C, gamma rays. Gamma rays pass through matter very, very easily. All right. And why it is not UV radiation? UV radiation is not a nuclear radiation. It belongs to radiations which are called electromagnetic waves. Okay, one would say, what about gamma rays? Gamma rays are also electromagnetic, but gamma rays have high frequency. The fact is that gamma rays have higher frequency compared to what? Compared to UV radiation. Okay, the higher the frequency of the electromagnetic waves, the faster or the more penetrating, or the more energy they have. Therefore, compared to UV radiations, gamma rays would penetrate much faster because they carry more energy than UV radiations, although both have the same speed of 3 times 10 to the power 8 meters per second. All right, so here we have used the fact that UV radiations are not nuclear. The keyword here is nuclear, are not nuclear radiations. Therefore, the answer must come from the first three, A, B, and C. And compared it to alpha particles and beta particles, gamma rays are more highly penetrating than alpha and beta particles. So the answer is C. All right. Okay, I hope so far so good. Remember, I'm addressing my Form 2 students. This is for you if you are writing JCE this year, this coming year, 2026. This revision is for you, and we have quite a number of revision series lined up for you, just for you to make sure that you face your JCE exams with utmost confidence, All right, so questions now 7 and 8 are based on this diagram here, the circuit diagram. So we are told that figure 3 is a circuit diagram. Use it to answer questions 7 and 8. So we have this one here. We have a cell here, over there, connected to a lamp or bulb, and then we have a switch here and a fuse. All right, which of the following is the name of a symbol Q? Okay, right away, this is a fuse, so there's no need to waste time. That's a fuse. Let me ask you to revise the other symbols, electric symbols, and their names. All right. So know all the symbols or electric symbols and their names. The arrows in the diagram show the direction of current. So this is current. As a matter of fact, this is conventional current. So the answer is D. Okay. Cannot be voltage, cannot be resistance, and cannot be electrons. Of course, there is a little bit of trick there. Current is basically the flow of charge, but these arrows are pointing that current is flowing from positive to negative. Therefore, it's better to just say current and not electrons. The real electron flow is from negative terminal to positive. All right. So if the arrow is pointed from negative to positive, then the answer could have been electrons, but that's not it. In this case, we are told that the direction is from positive to negative, which is just current. We call it conventional current. All right. We call it conventional current. Okay, so let's proceed. Question number 9. Question number 9. Move on to question number 9. Which of the following is the correct conversion of kilogram per 200 kilograms per cubic meter to grams per cubic centimeters? All right, to change density, this is density, by the way. To change density in kilograms per cubic meter to grams per cubic centimeter, you simply divide by 1,000. Divide by 1,000. And the opposite, going from grams per cubic centimeter to kilograms per cubic meter, you simply multiply by 1,000. All right, so in this case, without wasting time, you simply divide the 200 kgs per cubic meter by 1000. So this should be divided by 1000. Divide this by 1000. Just 1, 2, 3. So it will be 0.2. So 0.2 grams. So in this case, 0.2 grams. Therefore, the answer is going to be C. The answer is C. Take note. When you are changing density, which is in kilograms per cubic meter, to grams per cubic centimeters, you divide by 1000. When going up, you simply multiply by 1000. Okay, so we are doing the division part. Okay, so in this case, the result, the answer is 0.2 grams per cubic centimeter. All right, I'm talking to my JC students who are writing the manual exam in 2026. Please, if you have a child who is in Form 2 and they are writing their JC exams this coming year, share this video lesson to them to revise with me, and also help them to access other video lessons that I will be uploading in the near future. My name once again is Mr. Paul Chilola, your teacher on this platform. All right, number 10. We are still looking at section A. Number 10, the rate of doing work is called power. Okay, so this must be power. So the answer is power. All right, why not force? Force is a push or pull. Okay, energy is the ability to do work. Pressure is force divided by area. Okay, so the answer is supposed to be power. All right, power is the rate of doing work. All right, number 11, what is the weight of a 300 grams object on the surface of the moon? All right, on the surface of the moon. All right, so first you must know on the surface of the Earth, 100 grams, every 100 grams has a weight of 1 Newton. That means 300 grams is 3 Newtons on Earth. Yeah, so on the moon, the weight of the object becomes 1/60th of the weight on the Earth. So in this case, you have 3 goes here twice, which is 0.5. So the weight of this object on the moon is going to be 0.5 newtons. Take note, first of all, you need to change the grams on the moon, on the Earth, here on Earth. 1 Newton is the same as 100 grams. Okay, therefore, 300 grams, which is given, is going to be 3 Newtons on the Earth. Yeah, what about on the moon? On the moon, the weight of a body on the moon, it reduces by, it's taken to be 1/60th of the weight of the body on Earth. So on the moon, the weight on the moon is going to be 1/60th of 3. So 3 Newtons, 3, 1, 3, 2, which is half, which is the same as 0.5. So therefore the answer is A. All right. I hope so far so good. Where are you learning? Where are you learning? Share with me where you are learning, which school you are attending. It is going to be nice to know, just to know which school you are attending. All right. mention the school where you are learning. It is going to help me to strategize to give you content that prepares you well, that fully prepares you for the exams coming ahead. All right, so welcome once again. If you are new to the channel, consider subscribing. Consider subscribing to the channel so that you receive timely updates on the video lessons that I upload and share with you. My name once again is Mr. Pochilola. In case you have questions, don't hesitate to leave your comment, to leave your question in comment section below. I'll be very pleased to come back to you to attend to your query. Or you can contact me on the numbers that I shared earlier on. All right, figure number 4. Figure 4 is a diagram of a cell. Use it to answer questions 12 and 4. What type of cell is shown? All right, so this is a weight cell because it uses as an electrolyte, a solution to conduct. All right, so therefore this must be a weight cell. This must be a weight cell. All right, what name is given to the liquid represented by letter X? It is called electrolyte. Okay, it's an electrolyte. An electrolyte is a liquid that can conduct electricity. Great. All right, number 14. Given that the nuclear notation of uranium is this one here, what is the number of neutrons in uranium? All right, to find the number of neutrons, you simply subtract 235 minus 96. So 235 subtract 96. So 15, so you must have a 9 here. And then you have 12 minus 9 is 3, and then we drop down 1. So the answer is 139. 139. All right, make sure you are able to do this with just any element whose mass number and atomic numbers are specified. All right, which of the following is a better way of disposing radioactive waste? Okay, so radioactive waste can be best disposed by burying them, not by burning or recycling or incinerating. These ways are unsafe, okay, because radioactive materials can cause cancer, can cause skin problems, can cause respiratory problems, it can cause many problems. Therefore, they need to be properly disposed. The safest way to dispose of radioactive material is just to bury it in the ground so that it is out of reach of people. All right. Number 16 and 17 is going to come from the information given here. Cubes X and Y have densities of 10.5 grams per cubic centimeter and 7.1 grams per cubic centimeters respectively. Use the information given. All right, which of the following is true about the objects if placed in mercury whose density is 13.6? All right, X will sink while Y will float. No, X will not sink. Okay, for a substance, for an object to sink into another, that object must have higher density than the liquid in which it is being placed. All right, so in this case, X will sink while Y will float. No, both of them will float. Why? Because 13.6 grams per cubic centimeter is greater than either 10.5 or 7.1. X will float while Y will sink. No, both of them will float. Both X and Y will float. Yes, both X and Y will sink. No, so the answer is C. Why? Because both of them have densities that are lower than the density of Mercury. All right. Okay. All right. If you have questions, please don't hesitate to contact me, and then we shall look at the situation together and solve problems. When equal amounts of X and Y are mixed to produce an alloy, the average density will be less than density of X. All right. Greater than density of Y, less than density of Y, greater than density of Y. Let's go back to the information. All right, so the average density of the two, average, okay, just take the average first. So we have 10.5 add 7.2. That's the 7.2. The density of the mixture is going to be 17.6 divided by 2. That's 8.8, I think. Yeah, which is less than that of X, but greater than that of Y. Okay, so let's go back. Greater than density of Y, less than density of Y. Yeah, let's go back. Let's just look at the options. So what, when equal amounts, yeah, when equal amounts of X and Y are mixed to produce an alloy, the average density will be, okay, so it will be in the first place greater than that of, less than that of X, and but greater than that of Y. Less than X, yes, true. Yes. Greater than Y. Okay, so the answer is 1 and 4. Yeah, 1 and 4? Yes, 1 and 4, which is B. All right, so that's it. That required a little bit of thinking. That's okay. Question 18 and 19. Figure 5 is a diagram showing a method of charging an object. Use it to answer the questions 18 and 9. So we have these two bodies here. All right, where P is negatively charged, Q is the neutral. Name the method of charging Q when it is brought close to F. All right, so this is charging by induction. Therefore, is charging by induction. What charge will object Q possess? It's going to be positively charged, because the negative charges will be pushed away by repulsion. That means this end here will acquire a positive charge. Will acquire a positive charge. All right, that's great. Which of the following, number 20, the last one, which of the following pairs of atomic nuclei represents isotopes? Remember, isotopes have same number of protons but different mass numbers. So you just have to look at the bottom numbers. Okay, so in the first one here is 7. Here we have 7. This one here. We also have a 7 here. That means 1 and 3 are isotopes. So the answer therefore is A. All right, so thank you very much. This is section A. Please come back for section B. This should be ready by tomorrow. we are going to look at section B together. Once again, if you are a parent, please share this video with your daughter or son who is in Form 2 so that they can prepare fully well for a physics exam. All right, we also have revisions in other sciences such as biology and chemistry, as well as mathematics. My name once again is Mr. Pochilola. Bye-bye for now.